All right, guys, I hope you really love multiplication and division because it's about to get real. All right.
As if it wasn't real before this.
I don't know. That was all kind of easy, right?
Yeah,
Like, you got it.
easy. You got it. All right, so I'm trying to talk louder because I know you can't hear me very well. And I'm not like Busani, whose voice is super, super loud. So here's our next quest. We are trying to find the first three non-zero terms of the series x cosine of x. And x cosine x is, as you know, not a polynomial, but cosine of x can be written as an expanded polynomial or a series. And so what I'm going to do is just leave my x alone and say, I would like to multiply this by cosine, but that's too confusing and hard for me to do. So I'm going to expand cosine and write it like we just did with Smart Girl. That problem just last slide is 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial. It bears repeating because Busani wasn't here for this last time that the cosine function is an even function and it has even powers and even factorials so that you can remember which one is which. So this is going to go on. I only wrote 3 terms here because it said I only needed 3 non-zero terms, and I can see where I'm going with this. So I am going to FOIL. And that's a funny thing to say because that is not FOIL. FOIL is when you have 2 terms by 2 terms, but I like to call it FOIL because for fun. It's actually the distributive property. So when I distribute my x, I get x minus x cubed over 2 factorial plus x to the 5th over 4 factorial. And this is an approximation, a polynomial approximation for x cosine of x. So again, let me remind you what you do not want to do is write down all of the derivatives of x cosine of x and then plug 0 into them and write a big giant polynomial. What you do want to do is try to find a shorter way to do that. And this is our shorter way. So this one, also not a polynomial, but we do have an expanded version of sine that we can do. But notice, there's only one x. So don't start doing x minus each term of sine. You just take x minus. And then in parentheses, I'm going to replace sine with what we know it is because we remember that sine is an odd function. And so sine will have odd powers. So that's x minus x to the 3rd over 3 factorial plus x to the 5th over 5 factorial. I only need 3 non-zero terms, so I should stop here, right, Miss Busani?
Sure.
No. Wrong. Hi, Mr. Donaldson. Bye.
Oh, wrong, because the x minus x is going to make a 0 term. One more.
One more. Onward. Thank you so much for being so astute. My astute colleague has realized that I did not have enough terms and therefore would not have had 3 terms at the end of it. So sometimes you're going to make mistakes and you'll have to add terms later, like, oops, I guess I needed more. But just try to think ahead. So the next thing I'm going to do is distribute this minus, just the subtraction, to all of these terms. So then this might be overkill me doing this, but I might as well. So I'm making everything a positive now. And then, as you can see, these will cancel out, and this will be my series. Did I make a mistake, Busani? Is that right?
Yeah.
This will be in a series that approximates 1 minus the sine, or x minus the sine of x. How do you test and see if I did it right? Well, you check my work, but also you can graph this, and then you can graph this, and you can be like, holy Toledo, those are so close to each other. So we get a little loopy after teaching for a while. This is what I like to call infinite FOIL. Okay, it's not infinite FOIL, and she's over there looking at me like, this is so embarrassing. She's not even using the right proper terminology for the math that she's teaching. To which I say, would you like to get up here and teach this? You have no choice but to listen to me. You are my prisoner. Okay, so e to the x as an expanded form, and you can like flip back and look at that slide. It was x to the n. So e to the x is 1 plus x squared plus x to the 3rd. How many of these do I need? I don't know. Arctangent is the one that looks just like sine, but it doesn't have factorials. So it's going to start with x, x to the third, but not factorial with the 3, x to the fifth.
Wait, do we get factorials on EDX?
Yes. Okay, we are correct. Did I put that wrong on my slide? Oh, you guys should look back at the slide because I think there's a mistake. E to the x is not just x to the n, it's x to the n over n factorial.
You need all those derivatives to equal. It's what we did in class.
I know we did it in class. Okay. But I have a slide mistake.
It's okay. You guys caught it.
Okay, here. We're going to write note to students. Note to changed notes. E to the x is not just x to the n, it's x to the n over n factorial. That's what happens when you go out and take a drink of water when I'm teaching something. I will blame that entirely on not me. Okay, so now we're going to FOIL this out. So bear with me, I'm probably going to run out of time because this is such a mess. You want to take this 1 and multiply it by every single one of these terms. It's going to be a giant rainbow by the end of this. And how do we know when to stop? Well, we'll talk about that. The first term times the first term is x. I'm going to leave a space. The second term is this. Leave a space. The next term. Okay, done. Next, this guy times this, times this, times this. Now I have an x squared. I have x to the minus x to the 4th over 3 and plus x to the 7th, 6th over 5. I'm going to add these terms together. So if I'm think ahead about what terms are going to be left, because I only need 3 non-zero terms. Unless this cancels out, this is going to be one of them. This is going to be the next one. This will be the next one. I don't think I'm going to need any powers of 6 or 5, maybe not even powers of 4. But let's keep going for a second, because I don't want you to lose track of what terms matter. So my x squared next times x gives me x to the 3rd, so that's going to line up with this one. And then it gives me minus x to the 5th over 2 factorial times 3. Look, we're not going to need that, are we? We're not going to need this. We're not going to need this, we're not going to need that. This is going to be term number 1. This is going to be term number 2. The sum of these will be term number 3. I just want you to look now and see, is there any other way I can multiply anything that's left and get any powers of 1 or 2 or 3? Busani, is there any other way?
No,
Or am I
because you're
done?
going to be at x to the 4th next.
So my very next term is going to be x to the 4th, and I'll never be back to anything lower than that again? Is that correct, everybody? Do you see what I'm saying? So, like, we are going to call it. We're calling it. This is all we needed. Not even that, just this. And when we add that up, we get x plus x squared minus, help!
Oh my god. plus x cubed over 6.
No, is
Yes.
it? I'm going to believe her. You guys tell me if she's wrong.
Plus.
Okay. Here is a polynomial approximation for e to the x times arctangent of x. Look, I'm going to tell you guys a story, and if you're in Busani's class, you haven't heard this. My students know this so much. If you're stuck on a deserted island and there's a mad calculus genie, and he's like, you can't get off this island unless you can approximate for me within a millionth what is e to the 0.1 times the arctangent of 0.1. How are you going to do e to the 0.1 times arctangent of 0.1? You cannot do that with your stick in the sand. All you have is an island, a stick, 1 coconut. That's it. You can't do the e to the 0.1 arctangent of 0.1. There's no way. You don't have a calculator, right? You're not going home. But if you know a little bit of calculus and a lot of distributive property and maybe how to add fractions, which clearly I don't know how to do, you can get this polynomial approximation, and with a little bit of work with your stick in the sand, You can add 0.1 to 0.1 squared to 0.1 cubed. I know you don't want to cube 0.1. I don't care. Divide it by 6, add it together. You're getting off the island and you get to go home. And if you don't know what I'm talking about, Busani's class, I'm really sorry that you had to have her as a teacher because she doesn't talk about genies and psycho devil.
I don't tell you what calculus is really good for.
It's
I'm
really
sorry.
good for that. That's what it's really good for. Any questions? Speechless? She's speechless.
I am. Are we done?
Do we need to go?
Guys, I'm crying. I hope you're also crying, but not in a bad way. Cool. One more. We got time.
I don't know if we'll finish it. We'll start it because we don't like this problem at all. Because what do you think we should do with tangent? We don't have a series for it.
Sine over cosine. Let's do some long division.
Are you kidding me? Infinite long division?
Infinite long division sounds like the best way to make it through a coronavirus quarantine. I think you should do this up to 900 terms, guys. Because you're already done with those 900 terms on your calculator, and you've already watched all of Love is Blind, and you've already watched all of The Bachelor, because it's already over. I don't know what you're talking about. And
There's going to be a new one.
you've already watched all of the YouTube makeup tutorials,
And how many times have you seen all of The Office? 7? No? I mean, you can't watch it over.
all of Friends.
Friends got canceled off Netflix.
Oh, never mind.
Okay, never mind. Okay, do you remember? Let's help me here because I'm getting loopy.
I am good at long division.
Do you want to do it?
Sure.
Please,
All right,
let
y'all.
me hand off the pen.
It's been a long time since you saw me. So, when we do long division, polynomial long division, we're going to divide, we're just going to first look at the first term divided by the first term. We're going to take that quotient and we're going to put it up in our little answer space right here. So, x divided by 1 makes x. When we place that value, we're going to multiply it by the entirety of the polynomial that we're dividing by. So this becomes x minus x cubed over 2 factorial plus x to the 5th over 4 factorial. Now we're going to grab all of that and we're going to subtract. And you folks are going to do that at home. And we're going to start a new video in about, well, a second for us, but who knows for you. See you later.